This is the summary for Lesson 10, Calculating Slope. And so we have calculated the slope throughout this lesson, and I oftentimes have extended that to writing the equation for that line by looking at the movement of a slope triangle. And I'm going to continue to do that throughout this summary. So the authors give you this slope triangle, and they say you can figure out the slope using this slope triangle. And they tell you that it's the slope of the line is a -2/4 and or a -1/2. Well, I would like to look at that in a little bit more detail. And I wish they had given you some idea of a direction that you're moving from, in this case, moving from point B to point A. So A is where you end, B is where you start. And the slope is going to answer the question of how far are you moving as you move from point B to point A. How far are you moving in the vertical direction? And how far are you moving in the horizontal direction? Or how far are you moving in the horizontal direction this way? And how far are you moving in the vertical direction? So you're going to take where you end and subtract where you start. And so I wish they had included the signs of these values. So this is a movement of a -4 units along the x-axis and a movement of a +2 units along the y-axis. So that makes this slope a +2 over a -4, which equals a -2/4, which equals a -1/2. So you come up with the same answer, but it's one more visual part of this to include the signs for these movements along the horizontal axis and movement along the vertical axis. And so if you end up at A, and so now I'm going to take this y value right here, and I'm going to subtract these 3 units, and I'm going to lower this down to this horizontal axis here. Well, what's that going to leave for this length? That's going to leave these +2 units. So this is y -3. This is just writing the slope here. +2 over -4 gives you that same -1/2. So this is going to be y minus these 3 units right here, because I want to find out what this length is, this vertical length. So here's the y -3. And that's going to be over, that's going to be a ratio to x. Now this gets interesting, because now you're going to take where you end and subtract where you start. Well, you start at a +5 and you end here. So you're going to take this x value and subtract 5. So you're going to slide this slope triangle all the way in this direction to the vertical axis. You're going to subtract 5 units. Well, first of all, this is the x -5. So it's this x right here minus these 5 units that you start with. So you go out 5 units, and so you want to subtract that 5 units, and you want to find out what this length is right here. So here's the x -5. So we started out with y minus these 3 units. So that slides this slope triangle down to here. And now we're going to take this x value and subtract 5 units. So that's going to slide this slope triangle all the way over to here. And so that puts this point, the starting point, and that's what I've been focusing on, is moving that starting point to the origin. So once you do that, that tells you that this length in the horizontal direction is a -4 units, and this length in the vertical direction is a +2 units. So now this is a proportional relationship because it goes through 0. So now if you work through the algebra, you're going to see that the number of units in the vertical direction is a -1/2 times the number of units in the horizontal direction. So this is -4 units in the horizontal direction and -1/2 times a -4. Well, 1/2 of a -4 is -2, and the opposite of a -2 is a +2. So that's that +2 right here. So it's -4, +2. If you continue to work through this, you're going to get the proportional part of the equation, the m times x part, the slope times whatever value of x you use. So you work through, you add, if I subtracted this 3, I have to add this 3 back. That's right here. I changed this, this turned out to be a negative 1/2 times a negative 5, which is a positive 5/2. And you add 3. I'm going to change that 3 to halves so I can add these two together. You get 11/2. This remains a negative 1/2 throughout. Right here it becomes a negative 1/2 x, negative 1/2 x, negative 1/2 x, and so on. But now you're going to add where it crosses the y-axis, which is at a positive 5.5. So you have two parts to this equation now. You have the proportional part, which is a negative 1/2, whatever the value of x is that you choose. And then you have to slide that up to where you start, to where it intersects the y-axis. So if I choose a value of x equals 4, so what am I going to do? The proportional part says, what is a negative 1/2 of 4? Well, 1/2 of 4 is 2, and the opposite of that, or a negative 1 times that, is a negative 2. So this is going to go from x equals 4 to y equals a negative 2. All right, and then what do we have to do to get to this line? Because this equation describes all the points on this line. So how do you get back up to this line? Well, you have to add this 5.5. So you add 5.5 to get back up to that line. So add 5.5 to get to the line. Now, I wrote this out and I looked at this calculation of the slope, and you're going to see in the summary that the next page actually does the same thing, and it shows you both ways, but it's just with the numbers. You don't really see the movement of these slope triangles. But let's say that I now wanted to write the equation a second time, going from point A to point B. So B is the end, and I'm going to subtract the values for A. So now I'm going to move A to this origin. So I'm going to slide the slope triangle down here, and I'm going to slide it over so that A is now at the origin. Before we slid it over so B was at the origin. So if I slide it so that A is at the origin, I'm going to take point B, and I'm going to subtract these 5 units where A is. So this is the vertical, the y value for A is positive 5, so I have to subtract those 5 units. So that's going to be y minus 5, and there it is right there, y minus 5. So this is going to slide down 5 units. Well, where is it going to put this line down here? It's going to put this line at negative 2, right here at this negative 2. All right, so now I have to slide this slope triangle over 1 unit to get A to the origin. So that's subtracting 1. That's x minus 1. And that's right here, x minus 1. And so what do these lengths equal? So now I figured out for this slope triangle, sliding down here, I figured out that the horizontal length is x minus 1. So whatever this value is, it's x minus 1. So it's going to slide over 1 unit, x minus 1, and y minus 5. And that ratio is equal to negative 1/2. So what that says, once again, is that the length along the vertical axis, y minus 5, is a negative 1/2 times the length along the horizontal axis, which is x minus 1. So you're taking this 1 unit away from this horizontal length. And so for this example, what are you left with? You're left with positive 4. You take 5 units away from this vertical length. So once you take these 5 units away, what are you left with? You're left with negative 2. So negative 2 over positive 4 is going to give you the same negative 1/2. All right, so here's both triangles with removing all of the calculations for a moment and just isolating the movement of the slope triangle. So this is, if I go from b to a, I want to subtract b, the values at b, to get this b to the origin. So you subtract, this is y minus 3 and x minus 5. So y minus 3 and x minus 5. On the other hand, if I go from a to b, then I want to subtract the values at a away from where I end. So this is going to be y minus 5 and x minus 1. So y minus 5 and x minus 1. So sliding the slope triangle down. You're going to see in a moment that this kind of messed me up because the author started with this slope triangle, and you're going to see that this movement of a to the origin, you can see it better if you use this slope triangle right here. And I'm going to draw this in a few moments. And what that is a 180-degree rotation of this triangle to this triangle up here. But before we get there, let's work through this algebra a little bit. You have to come up with this same equation because it's the same line. It has to be the same equation because that line has not changed. So this says that y minus 5 is equal to negative 1/2 times x minus 1. Go through, do a little bit of the, I'm going to change this to adding a negative 1 because it's a lot easier if you change this to addition, and in this case adding negative 1. So negative 1/2 times a negative 1, that's like saying what's the opposite of a negative 1/2? Well, the opposite of negative 1/2 is positive 1/2. So it's negative 1/2 x plus 1/2. And I want to change this to halves so that I can add it. Well, actually, this is pretty easy. 5 plus 1/2 is 5.5. So I don't really have to change that. So if I subtracted 5, I subtracted 5 to get to this point right here. I have to add that 5 back. So if I add the 5 back, so it's negative 1/2 x plus 1/2, this 1/2 here, plus this 5, and that you don't have to change them to halves. It's pretty easy to add 5 plus 1/2. So that's y is equal to negative 1/2 x plus 5.5. And again, it's the same equation as down here. You get the same, you have to get the same y-intercept and the same slope, which is negative 1/2, negative 1/2. All right, so we looked at this before. Now let's look at it using this slope triangle for a moment. It's a little bit easier to see the movement. So now we're going to move A to this origin. It's a little bit easier to see this. So now we're moving from A to B. So we're going to subtract where we start from where we end. So if we do that, we're going to subtract these 5 units. And so what that does is it slides this slope triangle down 5 units. And the reason I like this one better is it puts this horizontal side on this horizontal axis. And that becomes a way to look at these in the future, is you want to move the horizontal side to the horizontal axis and then move the point that you're starting at to the origin. So you're going to slide this down to the horizontal axis. That places B right here at negative 2. So if you move this down 5 units, this is now negative 2, and move it over 1 unit, this is positive 4. So move it over this 1 unit, so it's positive 4 to get to this point, and a negative 2 to get to point B. So that slope is negative 2 over positive 4. That's a negative 1/2. So this is the better slope triangle to use to look at the movement of A to the origin. This slope triangle is better to use to look at B moving to the slope, moving to the horizontal axis, because now you're putting this horizontal side along this horizontal axis, or the x-axis. All right, so let's look at what the authors wrote just a little bit and make that connection. So they say you can use the points to figure out the slope. Rather than just using the slope triangle, this triangle here, you can use the points. And they write this in the beginning as moving from A to B. The reason I can tell that is they set this up to subtract 3 minus 5. So I circled those in red. So this is the y value. 3 minus 5 is equal to negative 2. So that's b minus a. So that's 3 for b minus 5 for a. And that is over. That's the change along the vertical axis, the vertical change, over the horizontal change. And the horizontal change is where you end, 5, minus where you started, 1. So that 5 minus 1 is equal to positive 4. So 5 minus 1 is equal to this positive 4. So they set it up as taking the values for b and subtracting the values for a. And I included in here what it would look like if you used y and x. So it'd be y minus 5 over x minus 1. And that's what we saw back here, y minus 5 over x minus 1. So what they're looking at first is moving from a to b, and they're sliding this a down to the x-axis and then over to the y-axis to the origin. So if you look, it's moving from a to b, so they're taking the b values and subtracting the a values. So taking the b values and subtracting the a values. Now I wish they had chosen something different than 5 for a value for these coordinates, so you don't get mixed up. These are different 5s. This is a 5 along the x-axis for b, and this is 5 along the y-axis for a. They are different, so don't get confused. They're not the same 5s. All right, so now what if you switch it? So then this next paragraph says, okay, notice that in each of the calculations we subtracted the value of point A from the value of point B. So it's B minus A. So you're moving from A to B, so you're subtracting where you start from where you end. So then they say, well, what if we switched it? Well, that's moving from B to A. So you're going to take the values at B and subtract those from A. So that's going to be, take the values at B and subtract those from A. So that's going to be 5 minus 3, 5 minus 3. Remember that this was x minus 3, and 1 minus 5. So 1 minus 5, and this was x minus 5. So go back to here just for a second. So now we're at this one, y minus 3 and x minus 5. So now we're moving from B to A. So we're taking the points at A, the coordinates of A, and subtracting the coordinates of B. So y minus 3 and x minus 5. And then finally, and you have to get the same slope. And then finally, they say you can't mix them up. You can't decide, oh, I'm going to subtract 3 minus 5, and then I'm going to subtract 1 minus 5. You have to go in the same order in each case. If you choose to subtract A from B, that has to be 3 minus 5 over 5 minus 1. Or if you choose to subtract A from B, if you choose to subtract B from A, then that has to be 5 minus 3 over 1 minus 5. You can't mix them up. If you mix them up, you're going to get the same values of the slope, but they're going to be opposite signs. And they just go through and say you can tell that because you're going to get a positive slope, whereas this line is clearly a negative slope. It's moving from the top left to the lower right. Positive slope, the line would move from the lower left to the top right. All right, so this is a lot, and I know that I'm including in here something that can be confusing, but the more and more you look at it and realize that you're just moving these triangles around, the more you'll start to be able to see the math, and it will make more sense to you because you start fitting that into your thinking. So you could actually take any of these points and subtract y and subtract x and make it equal to -1/2, and you're going to get the same equation. Subtract y, subtract x equal to -1/2. You're going to get the same equation, whatever point you choose on this line. You're going to slide it down to the horizontal axis and slide it over to the vertical axis, so over to the origin.